Okay, this is a video on limiting reactant problems. Generally speaking, the limiting reactant is the reactant that runs out first. The limiting reactant is the reactant that runs out first. The best analogy I can give is if you have, say, 12 graham crackers, and I'll say 5 pieces of chocolate, and 5 marshmallows. How many different s'mores can you make? And let's say the recipe for a s'more is 2 graham crackers plus 1 piece of chocolate plus 1 marshmallow yields 1 s'more. Okay, well, in the case of this, I can only make 5 s'mores. Why is that? Because my chocolate and my marshmallows will run out. I still might have graham crackers left over, but because those have run out, I can't make any more of my product. That makes the chocolate and the marshmallows my limiting reactant. Okay, so how can this actually be used for a chemistry problem? The example I'm going to do out for this is question number 204 in your textbook, and specifically I'm going to do both A and B. So let's do 204A first. Okay, and they ask, if 100 grams of CUS and 56 grams of O2 are available, which is limiting? This is on 204A. And that's according to this equation right here. So grams are essentially useless in stoichiometry. So whenever you see a mass of something given, your first step in any stoichiometry problem has to be to turn it into moles. So I have 100 grams of CUS. Grams are the unit I start with, so it has to go on bottom. Moles are what I want, so that goes on top. And remember, I use my periodic table to go between grams and moles. Turns out the mass of copper, if I look up my periodic table, is 63.55. The mass of sulfur is 32.07. I add those together, and I have 95.62 grams. Okay, 100 divided by 95.62. Do that out in my calculator real quick, and it looks like I have 1.04 moles of CUS. Now I have to do the same thing for my O2. I have 56 grams of O2. Divide by grams. Oxygen is 16 on the periodic table, so because there's 2 of them, it's 32 grams in 1 mole. And 56 over 32 is 1.75 moles of O2. Okay, so back to the original question, which one is limiting? Now, my balanced equation tells me that I need 2 copper sulfides for every 3 oxygens. So in other words, for every 2 of these, I need 3 of these. Well, here's a little quick math trick to figure this out. I'm going to divide this by its coefficient and this by its coefficient. And what that'll essentially do is cancel out what the coefficients are here, and then I can just compare the amounts of moles to each other. So 1.04 over 2 is 0.52. 1.75 over 3 is 0.58. Okay, I have fewer amount of moles here than I do here, so the copper sulfide in this is going to be my limiting reactant. That's the one that's going to run out first. This one is what's known as my excess reactant. So I have extra of that at the end. There's going to be a little bit of it left over. Okay, so that's how to determine if something's limiting. Now how to actually do a problem with it. And 204B is a really good example of this. What mass of CuO can be formed with this amount of CuS and this amount of O2? Well, whenever you're given amounts of both your reactants, that's a sign that you need to discover which of your reactants is limiting before you can actually do anything. So that's what I'm going to go through right now. So on 204B, they give me 18.7 grams CuS. And again, to start off, I have to determine the limiting reactant. Okay, so determining the limiting reactant is my goal here. Again, when they give me grams, I have to turn it into moles before I can do anything. Grams goes on bottom, moles goes on top. Before I got the mass of CuS, it was 95.62, so I'm just going to use that again here. 95.62 grams per 1 mole Divide that out super quick, 18.7 over 95.62, and that is 0.200 moles of CUS. Got to do the same thing for O2 now. So this tells me I have 12 grams of O2. I'm going to put the molar mass of O2 on bottom. Turns out that's 32. And 12 grams divided by 32 grams per mole is 0.375 moles of O2. Now I need to take my chemical equation into account. Now I need 3 O2s for every 2 CUS's. So I'm going to divide each by their coefficient. And so that's going to come out to 0.1. And that's going to come out to 0.125. So I have less of this after I take the coefficients into account than I do of this. So this is going to be my limiting reactant. Okay, why is that important? The limiting reactant is what determines when the reaction's done. In other words, once I've run out of my limiting reactant, I don't have any more reaction. So my next step here to solve this problem is to use the limiting reactant. Use the limiting reactant for stoichiometry. The excess reactant's essentially meaningless. It's the limiting one that's going to determine how much product I've made. So I'm going to start with this amount of copper sulfide, because that's the amount that I actually have. Not this 0.1. That was just kind of a mathematical trick to figure out which one was limiting. I actually physically have 0.2 moles of CUS. So that's what I'm going to start with for my stoichiometry problem. Okay, I have moles of CUS, so now I'm going to determine how much of my product I have, and we're looking for CuO at the end of this. So CUS is going to go on bottom. Moles of CuO go on top. And my balanced chemical equation tells me there's 2 CUS's for every 2 CuOs. Moles of CUS cancel each other, and I'm left with moles of CuO. They want to find the mass of CuO, so I'm going to have to turn this into grams. So moles go on bottom. Grams of CuO go on top, so that way those cancel each other. And it's 1 mole per, well, now I got to look on my periodic table again. It turns out copper has a mass of, again, 63.55. Oxygen has a mass of 16, so 0.55 times 7, so 79.55 grams per 1 mole. And now I'm just going to do the math out for this. 0.2 times 2 times 79.55 divided by 2. And that comes out to 15.91 grams of CuO. Okay, so what I need you to get out of this video is, first off, what is a limiting reactant? Well, it's the reactant that runs out first. And it's what determines how much product is going to be made at the end of the day. How do you determine the limiting reactant? Well, if you're given masses of each of your substances to start off with, convert them to moles first, then divide by the coefficients to take into account whatever ratio you have here, and whichever lower molar amount you have at the end of that, that's your limiting one. That's what you're going to use for stoichiometry. So whenever you're asked to determine how much will be formed, like the second problem, use your limiting reactant going forward.